electrons, p4 electrons, s2 electrons, p4 electrons, s2 electrons, p4 electrons. That's why they have 6 plus 2 plus 4 equals to 6. So they are placed in 16th group. So we used to call this as 6th group. Nowadays we are calling it as 16th group elements. So this is the position of these elements. Second point to be noticed here, oxygen, sulfur both are non-metals. So these two are non-metals, whereas polonium is a pure metal. Polonium is a pure metal, whereas selenium, tellurium both have the properties of metal as well as non-metal. So we call them as metalloids. So this is the general overview of these 16th group elements. Okay, and physical properties we should know. We have already covered all these physical properties. So what happens from top to bottom? Atomic size increases. Why atomic size increases? The differentiating electron every time entering into a new subshell, new shell, not subshell. Every time it's entering into, so in oxygen it is present in the second orbit, in sulfur it is present in the third orbit, in fourth orbit in selenium, fifth orbit is in tellurium, and the sixth one is in polonium. So these are being filled up. That's why the atomic size increases, right? And atomic size and ionization energy, I'll write here atomic size. So atomic size increases. Then you have to talk about ionization energy. Cheppandi, ionization energy and atomic size are inversely related. They are inversely related, so atomic size decreases from the top to bottom. Right? Is it clear? You have to unmute and you have to talk. You don't stand by. Hello? Otherwise, I will call one by one.
Yes.
This relation we know it, right?
Yes, sir.
Right. So one more important point is electronegativity. Electronegativity. What is the order of electronegativity? Can anyone explain? Electronegativity and size are inversely related, but there are so many exceptions. So here the element with the highest electronegativity is what? So meeku oka vishayam cheppali, idi recent ga JEE lo adiginatuvanti question. I'll show it. So JEE 2025 January session lo ee question adigarandi. January session lo the element with the abnormal electronegativity is. So this question is being asked. Cheppandi, which one is it? I'll show the values also. Right? So before answering this question, we'll talk about two more things. The element with the highest electronegativity is what? Fluorine, everybody knows. The element with the highest electron gain enthalpy is chlorine, isn't it? So in P block, the highest element with the highest electron gain enthalpy is chlorine, right? So second element has got the highest gain enthalpy. So here the sulfur has got highest, the electronegativity is greatest for oxygen, but electron gain enthalpy for sulfur is very high. So this is the question asked in JEE 2025, right? So which of the following has got highest gain enthalpy? So this type of question is being asked. I'll show the values of these also. This is our NCERT book. Of course, this is old NCERT book. So we have got this table. Can you see the table?
Yes, sir.
Yeah. Just I'll mark few things here. So this is atomic number. So these are the numbers given here. Right, atomic size is okay. Atomic size electron configurations what we have written, those were written with the what noble gases के साथ उन्हें लिख दिया है. Covalent radius ionic. Electron gain enthalpy, this is what you have to remember. So oxygen is how much? Minus 41. Sulfur is minus 200. Selenium is minus 195. Tellurium is minus 190. Polonium is minus 174. So what is the value here? The value of minus denotes that, so it's an exothermic reaction. Minus value has no significance with the value, it denotes that the energy is being released. But magnitude of the value किसका सबसे highest है? बोलिए किसका highest है? Sulfur, isn't it? So this is the sulfur element, sulfur का सबसे highest है. Same is also seen in 17th group. So ఇక్కడ fluorine ఉంటుంది, ఇక్కడికి వచ్చేసరికి you got chlorine, right? So chlorine has in P block second element has got highest electron gain enthalpy. This must be noted at any cost. Okay, so what would be the order? You can put them in order. So 200 greater than 195, greater than 190, greater than 174, and the last one has got the least one, that is 141 is here. This is for oxygen. Do you understand? ऑक्सीजन का प्लेस कहाँ पर है? लास्ट प्लेस में है. So please girls, can you confirm this information? Can you remember this till your exam? Your mains exam is not too long. Are waiting? Okay, I'll invite them. Bhavita Satyasri.
Class, sir.
The class time is 9:20. You should be by 9:20. I have started class at 9:30. Okay, you should be earlier. Just join at the time. Okay, I'll give the 10 minutes time to join. Okay. Right. So can you reckon the abnormality here? Abnormality को आपको identify करना है. You should able to write them. Malevro vachir sir. They start playing it, sir. Who is that? So sulfur is the most element with the highest electron gain enthalpy. Let us also see some other properties of these elements. So if it is abnormal, you have to mark it. Otherwise, you don't have to. Ionization enthalpy 1314, 1000, 940, 869, 813. So it's a regular order. Size increases, ionization energy decreases. The question cannot be asked from this. Electronegativity. So electronegativity में भी कोई abnormality नहीं है, देख लीजिए. So it's gradually decreasing. Density is also increases. Obviously it is increasing. Melting points, boiling points में कोई changes नहीं है. So only thing you should remember is this one. Okay, sulfur is the most electronegative, the element with the highest electron gain enthalpy. Okay, right. So we'll go back to our blackboard here. So this is our blackboard. Now we'll talk about oxidation numbers. Oxidation numbers of these elements. This is another important topic here which should be studied from the physical properties only. So since they have NS2, NP4 configuration, so they can use all these electrons. So when they use different electrons, they will exhibit the different oxidation numbers. If they lose or if they use all electrons from s orbital, from p orbital, they are going to show plus 6 oxidation number using s electrons as well as p electrons. Both electrons are used. So this is the plus 6 is the general oxidation number. But if they use only p electrons, not s electrons, they will exhibit plus 4 oxidation number. They use only s electrons. Only p electrons. They use only p electrons, they will show the plus 4 oxidation number. So these are the most general oxidation numbers. There is one more general oxidation number. They have 6 electrons and they are short of only 2 electrons to get octet configuration. That's why the minus 2 is also another general oxidation number for them. So these are the 3 oxidation numbers: plus 6, plus 4, minus 2 are the general oxidation numbers of these elements. Right. So one more point to be noticed here. Oxygen is the second most. The oxygen is the element with the second most electronegative element. Right. So who is the other one? The first most electronegative element is the fluorine. So only oxygen can exhibit plus oxidation state when it is with the fluorines. Otherwise it always exhibits minus 2 oxidation number only. So I'll write the statement here. Only in its fluorides, oxygen exhibits plus oxidation number, plus 2 or plus 1 oxidation number. This we should remember. I'll write the compounds also. The first one is OF2, another one is O2F1. O2F2, these are the 2 compounds where oxygen oxidation number, in this case what is the oxidation number? Plus 2. In this case what is the oxidation number? Plus 1. I am not drawing it, so these 2 compounds you should remember. The only 2 compounds known to us where oxygen is in positive oxidation number is these 2 compounds, OF2 and O2F2. Because in all oxides, for example, if I take, someone is inside, sir, someone is in again. Sahasra, Kajipeta Sahasra, what's the time of the class? Amma ippudu vachinavu nuvu? Sahasra, are you there? Can you talk? Yes, Sahasra, you should be on the time. You are very late. It's okay. First class, no problem. You are welcome now. So if you come late, I have to do many things. I have to stop the class and I'll ask you to, I'll let you in. So that's the point here. So these are the 2 compounds you should remember where oxygen's oxidation number is plus 2. Otherwise it is only those oxidation numbers. And oxygen also shows 3 different oxidation numbers: minus 2 oxidation number, minus 1 oxidation number, right? Minus 2, minus 1 and minus half oxidation number. So these are possible in, this one is possible in oxides, this one is possible in peroxides, this one is possible in superoxides. So these are the oxides and their oxidation numbers. So oxides and oxidation numbers we should remember. Okay, right. Where do we have it? Oxidation numbers, chemical properties, electron gain, enthalpy. Yeah, here is the oxidation number. So just I'll read this one. You can see here the oxidation states and trends, chemical reactivity. The elements of the 16th group elements exhibit a number of oxidation states The stability of -2 oxidation state decreases down the group. Polonium hardly shows -2 oxidation number. Polonium being a metal, it shows only +2 oxidation number. Since electronegativity of oxygen is very high, it shows only negative oxidation number. చూడండి ఇక్కడ ఎక్సెప్ట్ ఇచ్చాడు. దీస్ ఎక్సెప్షన్స్ ఆర్ రెగ్యులర్లీ ఆస్క్డ్ ఇన్ ద క్వశ్చన్స్. సో యూ షుడ్ రిమెంబర్ దిస్ వన్. సో ఎక్సెప్ట్, విల్ గో టు నెక్స్ట్ పేజ్. Except in case of, you can see here, in case of oxygen difluoride and in oxidation state is +2 and the other one exhibits +2, +4, +6 oxidation numbers. Just we have seen +6 is due to use of all the electrons, +4 is for only p electrons, +2 is possible by these elements when oxygen difluoride like compounds are formed. The oxidation states, but +4, +6 are more common oxidation numbers. Sulfur, selenium, tellurium usually show +4 oxidation state in their oxidation in their compounds. The oxygen +4 with fluorine. So the stability of +4 oxidation state decreases down the group. The stability of +4 oxidation state increases. इसका reason भी ये है, inert pair effect. So वो भी एक बार चेक करेंगे. So what is saying here? So the general oxidation number is +4 as well as +6. So इनमें से stability of +4 oxidation state increases and +6 decreases. So polonium के लिए you have two oxidation numbers. One is +4, another is +6. So +4 is the most stable. इसका reason भी बताया उन्हें. What is the reason? Inert pair effect is the reason. Right. So now we'll see these anomalous properties of oxygen. So we know that every element in the first element of every group has some anomalous behavior, abnormal behavior. तो इसका सबका रीज़न एक ही है. साइज छोटा है, स्मॉल साइज, lack of d orbital. So these are the major two reasons. We'll see this also here. What is given here? The anomalous behavior of oxygen, like other members of P block present in the second period, is due to its small size. You can see this, its small size and high electronegativity. One typical example effects of small size and high electronegativity is presence of strong hydrogen bonding in H2O. H2O lo hydrogen bonding untundi, so which is not found in H2S. This is another reason. And the other reason is absence of d orbital in oxygen limits its covalency to 4 and in practice rarely exceeds to 2. On the other hand, in case of all the elements and groups, valency shell can be expanded to covalency up to 4 only. So these are the anomalous behaviors of oxygen. Okay. So these are the oxidation numbers. So we'll go to the next part. What do we talk about? Chemical properties. So chemical properties में क्या पढ़ना है? Chemical properties have got chemical properties का compounds है. First one we to talk about hydrides. Second one we talk about oxides. Third one we talk about halides. So these are the three major things we talk about. మళ్ళీ ఎవరో వచ్చారు సార్ మళ్ళీ ఎవరో వచ్చారు. కల్లు రెడ్డి సహస్ర అన్నట్టు. సహస్ర కల్లు సహస్ర అవనే సార్. కల్లు రెడ్డి అని వచ్చిందంటే కల్లు సహస్ర. వై ఆర్ యూ లేట్? అమ్మ అన్మ్యూట్ చేసి మాట్లాడాలి. సహస్ర ఆమెనేనా సార్ కల్లు రెడ్డి?
శాస్త్ర సార్.
కల్లు రెడ్డి అని వచ్చింది, ఆమె మాట్లాడతలేదు కొన్ని ఉండే. ఓకే, yeah, we'll talk about hydrides, oxides, halides. I'll give the general information, then we'll go into the deeper version. Hydrides are MH, so hydrides would be MH2, or in fact I'll write it like this, H2M. They are H2M type of hydrides. Oxides are MO2 type of oxides as well as MO3 type of oxides. Halides are MX4 tetrahalides, M hexahalides, so MX6, X6, MX2 type of halides also found. Just we'll take the overview and then we'll go into this one. What is should be it? What you have to do here, you have to replace this M by the metal. You have to remove not the metal, by the element. So M should be replaced by the 16th group elements, then you will get the halide oxide of any element. For example, if I replace this one by oxygen, what do I get here? H2O. If I replace it by sulfur, I get sulfur, hydrogen sulfide, hydrogen selenide, hydrogen telluride, hydrogen polonide. So these are the hydrides of the 16th group elements. You should remember. तो यहाँ सल्फर आप रिप्लेस कर सकते, सो यू गेट सल्फर डाइऑक्साइड. ऑक्सीजन का ऑक्साइड एक ही पता है, दैट इज O3 इज कंसिडर्ड एज ऑक्साइड ऑफ ऑक्सीजन. यू कैन ऑल्सो राइट इट लाइक O2 लिख सकते हैं आप. एंड SeO2 सेलेनियम डाइऑक्साइड, टेलुरियम डाइऑक्साइड, polonium dioxide, but polonium is a radioactive element, so it is not known very much. Even here also it is not that stable. Trioxides are SO3, SeO3, tellurium trioxide, right? So these are the general halides. So MX type of halides very well known are SF4, SCl4. These are the two which are very well known. इसके लिए so the most famous example everybody knows, that is SF6. So MX2 type low, you have got SCl2, even you have got OF2 type of oxides are there. So these are the general chemical properties which we should talk about. इसमें जनरल प्रॉपर्टीज ऑफ हाइड्राइड्स पढ़ना है, इसका फिजिकल प्रॉपर्टीज भी पढ़ना है. व्हाट आर द नेचर्स ऑफ दीज वंस शुड बी स्टडीड. ऑक्साइड्स में भी सल्फर डाइऑक्साइड का केमिस्ट्री है पूरा, प्रिपरेशन एंड इट्स प्रॉपर्टीज. सल्फर ट्राइऑक्साइड का भी प्रिपरेशन प्रॉपर्टीज है. हालाइड्स का स्ट्रक्चर्स आपको पता करना है. प्रिपरेशन तो इजी प्रिपरेशन ही होता है. ओके, so we'll talk about hydrides. Okay, yeah, we'll take hydrides of these group elements. Hydrides are H2O, H2S, H2Te, Se, then comes H2Te. Generally we talk about only these four. Okay, sir, ఎట్లా వస్తుంది? Okay, so these ones we should talk about. First of all, so oxygen has got connected to two hydrogens in this way, right? The same structure is there. We talk about this bond. This bond position, we should talk about this position of it one, right? So in hydrides, in first H2O, what do we have here? In H2O we have got hydrogen and oxygen bond. here you have hydrogen and sulfur bond, here you have hydrogen and selenium bond, here you got hydrogen and tellurium bond. So these are the bonds. Can anybody say what happening to this bond? Is bond length increasing or decreasing?
Increasing.
Yes, increasing. Yes, correct. It's increasing. Why it is increasing? Because size of these elements increasing. इनका साइज इंक्रीज हो रहा है. सो हाइड्रोजन तो कॉमन है सबके पास, एंड ऑक्सीजन, सल्फर, सेलेनियम, टेलुरियम, द साइज इज, द बॉन्ड लेंथ इज इंक्रीजिंग एज वी गो लॉन्गर. व्हाट हैपेंस हियर? So this bond looks like strong. So this bond is very strong, whereas this bond is weak. Can you tell which bond can be easily broken down? Is this one or is this one?
H2TE.
H2TE bond can be broken down easily because of this longer bond. This bond is very long bond. Long bonds are weak bonds. This bond is short bond, and short bonds are very strong bonds. So you need more energy. अगर आपसे मैं ये क्वेश्चन पूछूं, उल्टा क्वेश्चन विल बी आस्क्ड इन द डिफरेंट वे. इनमें से सबसे जल्दी कौन हाइड्रोजन दे सकता है? ये लॉन्ग बॉन्ड है, इसको जल्दी काट सकते हैं आप. थोड़ा सा एनर्जी दिया है तो ये टूट जाएगा, इसमें से हाइड्रोजन बाहर आ जाएगा, जल्दी आ जाएगा, राइट? तो इसमें से हाइड्रोजन बाहर नहीं आएगा क्योंकि इसका बॉन्ड कैसा है? ये स्ट्रांग बॉन्ड है. वीकर बॉन्ड्स आर ब्रोकन डाउन इजीली. इट इज इजी टू कट द वीक बॉन्ड्स टू रिलीज द हाइड्रोजन इजीली. दैट्स व्हाई दिस हाइड्रोजन इज रिलीज्ड इजीली, whereas this hydrogen is not released. If anyone which donates hydrogen, donor of hydrogen is called as reducing agent, isn't it? So can you tell which one is the strongest reducing agent? You have 4 options, 1, 2, 3 and 4. Strongest reducing agent ever. Who will answer it? ఇక్కడనే ఆన్సర్ ఇక్కడే ఉందమ్మా, చూడండి. దిస్ బాండ్ ఈజ్ బ్రోకెన్ ఈజీలీ బికాస్ ఇట్స్ లాంగ్ బాండ్ అండ్ వీక్ బాండ్. సో ఇట్ కెన్ డొనేట్ హైడ్రోజన్ ఈజీలీ. సో ఇట్ ఈస్ ద స్ట్రాంగెస్ట్ రెడ్యూసింగ్ ఏజెంట్. మేక్ సెన్స్, రైట్?
Yes, sir.
Right. This bond is stronger and it cannot be a donor of hydrogen. So therefore it cannot donate the hydrogen that easily. So that's why it is the reducing property increases down the road. Right. So this is the first thing about these hydrides. We'll talk about second thing about these ones. Inka boiling points we have to check. Right. So I'll clear it off to talk about the boiling points. So boiling points, how do you relate the boiling points? Boiling points are directly proportional to molar mass. Higher the molar mass, higher the boiling point. Lower the molar mass, lower the boiling point. What do you say? Antena amma? All gases are very weak, so they have molar masses very less. That's why they are gases, isn't it? You don't find any gas whose atomic number is more than 18 or 20. 20 के बाद कुछ भी नहीं मिलेगा except noble gases. सारे के सारे solids होंगे या liquids होगा. So molar mass, H2O molar mass is 18, we know it. And this is going to be 34, 18, and this selenium is going to be very much bigger, tellurium is bigger. So what would be the order expected order of boiling point from top to bottom? Cheppandamma. Which one should be expecting to have the maximum boiling point? this one should be expecting to have the maximum boiling point, right? So when you consider this molar mass into account, if you this one is taken into account, so hydrogen telluride has got the more. Lekin the thing is, water has got వాటర్లో ఏముందంటే hydrogen bonding is present. Due to presence of hydrogen bonding in water, water has the highest boiling point of all. So we know that water boils at 100 degrees Celsius or 273 Kelvin temperature. This is very, very high. Otherwise, the remaining are the gases at room temperature. Remaining ones are the gases at room temperature. H2O is, we know that it's a liquid. इसका रीज़न एक ही है. क्या रीज़न है? हाइड्रोजन बॉन्डिंग. ये क्वेश्चन అయితే రిపీటెడ్గా అడుగుతూనే ఉన్నారమ్మా. యూ షుడ్ ఏబుల్ టు దీని యూ హ్యావ్ టు రిమెంబర్. విల్ గో టు అవర్ NCERT. If you don't have this NCERT, I'll share it in your group. You can read this. Okay, yeah. So we got the hydrides here. Just I'll read here. Okay, the reactivity with the hydrides. So all the elements of group 16 from hydrides of H2E type. So oxygen, selenium, tellurium, polonium. Some properties of these hydrides are given in the table 7.7. Their acidic character increases from H2O to H2T. Increase in acidic character can be explained in terms of decrease in bond enthalpy for the dissociation energy. They can be donors. Bond down the group. Owing to the decreasing enthalpy for the dissociation of He bond down the group, the thermal stability of hydrides also decreases from H2Te. All hydrides except water possess reducing property. This character increases from H2S to Te. So here H2O is not a reducing it has no reducing property. Remaining have got reducing property, and this is the order here. Yeah, this is the table we should study here. Yeah. So first one, melting point. Iska melting point highest hai? Highest melting point is also for water, right? 273. That is 0 degrees Celsius. Right? Ice is formed at 0 degrees Celsius. That is 273. H2S is 188. H2SE is 208 and H2TE is 222. Whereas boiling point chudandi 373 is for water. This is very high. 213, 232, 269. So where do you place this one? So this one is expected to be here. So if I place the order, so this is bigger, this is less, this is further less. That means idi ikkadiki vastadi. That's what you have to remember. H2O, H2O, H2O. రెండు ఎక్సెప్షన్స్ ఉన్నాయమ్మా. ఒకటి H2Oది, ఒకటి సల్ఫర్, highest electronegativity. These two things you should remember. And remaining we also see the EH bond length, element and hydrogen bond length in picometers. 96 in oxygen hydrogen, 134 in H2S, 146 H2SE, H2TE is 169, increasing. బాండ్ యాంగిల్ కూడా ఒకసారి చూడాలి. బాండ్ యాంగిల్ ఇన్ H2O ఈజ్ టెట్రాహైడ్రల్ యాంగిల్ క్లోజ్ టు 109 degrees, whereas the remaining ones have got equivalent to 90 degrees के करीब है. So this is non-participation of hydrogen bonding. That's what we talk about. Dragos rule में we discuss it. Only H2O can be a donor of the electrons due to this bond sp3 hybridized state, whereas H2S, H2SE, H2TE, all these are they are not the, what do you call them, they are not the ligands at all, because of these reasons. We talk about the Dragos rule in first year class mein, we have seen this. Okay, so this is about hydrides. Okay, we'll take a few questions here. మొన్న జేఈ మెయిన్స్లో అడిగిన క్వశ్చన్ దొరుకుతుందేమో చూద్దాం, ఒక్క నిమిషం అన్న. Go to 32, page number 32. Yeah, these are the few questions asked last time. One is about 15th group elements, large difference between melting point, pH 3 shows the electronegativity of H2S2. Yeah, these questions were not there, right? Okay, so this is about hydrides. So any questions? Yeah, otherwise we'll move on. We'll go to ऑक्साइड्स चेक करेंगे. Yeah, we have oxides of the 16th group elements. So oxides law, first we'll talk about, there are two types of oxides. One is MO2 type of oxides. He mentioned it as E, right? So EO2 type of oxides, EO3 type of oxides, right? So these are called dioxides. These are dioxides, these are trioxides, right? So dioxide example em cheppandi, SO2, SeO2, TeO3, TeO2, these are the oxides. So this is going to be SO3, SeO3, TeO3. So these are the oxides of these metals. We should remember oxidation numbers we have to talk about here. Oxidation number in dioxides it's +4, here it is +6 oxidation number, right? +6 is the highest oxidation number. +6 is the highest oxidation number. If you check these oxidation numbers, so it starts from -2, right? So 0, +2, +4, +6. So these are the highest oxidation numbers. Out of these oxidation numbers, the top oxidation number is this one. This is on the top and this is on the bottom. So these two oxidation numbers are non-disproportionatable oxidation numbers, whereas the oxidation number +6 can only converted into +4, +2, yeah 0 or -2. Yeah, -2 can be increased to these oxidation numbers. This is how the process goes. But for fourth case, it can be oxidized to +6, it can be reduced to +2. +2 can also be oxidized to +4 and +6, whereas it can also be reduced to -2. That's why these intermediary oxidation numbers are disproportionable. They undergo disproportionation. They can be oxidized, they can be reduced. But these ones can only take the electrons. These are only act like a reducing agents. These can act like an oxidizing agents. These are +6 oxidation number is only oxidizing agent, minus 2 can only reducing agent, but intermediate oxidation numbers can be both. So what I mean to say here, SO2 can be a reducing agent, can be a oxidizing agent, whereas SO3 is only oxidizing agent. It can only oxidizing agent, it cannot be a reducing agent, because it has already, for oxidizing agent it has to gain the electrons. For reducing agent it has to lose the electrons, but already all valence electrons are lost here. So that's why it cannot lose any more electrons at all. So that's why it cannot be a reducing agent, it can only be oxidizing agent. But these oxides are oxidizing agents as well as reducing agents, right? So only oxidizing, reducing property, and we'll discuss about these oxides also here, right? The reactivity towards the oxygen. All these elements form oxides like EO2 type and EO3 type of oxides, where these are the elements. Ozone O3 is the only oxide and sulfur is dioxide, are gases, while selenium dioxide is solid. Reducing property of dioxides decreases from sound వస్తలేదా? ఎందుకు సార్? హలో, యూ లాస్ట్ యువర్ నెట్వర్క్ కనెక్షన్ సార్. అయిపోయింది సార్, కనెక్షన్ అయిపోయింది. ఓకే సార్, విల్ క్లోజ్ ఇట్.